Okay, children, we are going to begin today exercise 7.1. Earlier, you have got information regarding the different formulas and all those things. So, today we'll begin with the exercise. Okay, so now exercise 7.1. Now, integration, if you want to find integration, you are supposed to do antiderivative, because meaning of integration is antiderivative, the opposite of that, right? So I want to actually find integrate sine of 2x. So basically what I have to do to integrate sine of 2x means I have to find antiderivative of sine of 2x. So I wish to calculate what is the antiderivative of sine of 2x. Now, what comes to your mind कि what will you differentiate? यहाँ आपको सोचना है what will you differentiate so you will get the answer sine. So you if you differentiate cos, you will get the answer as sine. So let me begin with that. So I write d by dx of cos of 2x, d by dx of cos of 2x, and that is going to come, my answer to that is minus sine of 2x. So what was the differentiation of cos of 2x? Cos का differentiation will be minus sine. So cos of 2x, so minus sine of 2x. But you know the chain rule that if you do not have the simpler form of x over here, so you differentiate that bracket back again. So I will have into d by dx of 2x, into d by dx of 2x. Okay, so what is that answer? Differentiation of 2x, differentiation of 2. So 2 is a constant and x, if you differentiate, the answer is 1. So the answer to that is minus, this minus sign as it is I wrote, differentiation of 2x, the answer is 2, and now I write this sine of 2x. Now what I do is, next step, this was what? This was d by dx of cos of 2x. Now what I do is, I bring down this minus to cross multiply it over here. So I will have minus 1 upon 2 into d by dx of cos of 2x. This whole thing is equal to sine of 2x, is equal to sine of 2x. That means if you integrate sine of 2x, you are going to get, this is how you are going to get through what is the antiderivative of that. So therefore antiderivative of sine of 2x is going to be minus 1 upon 2 into d by dx of cos x. So my first question was find antiderivative of sine of 2x. तो मैंने तुरंत सोचा कि साइन ऑफ 2x अगर मुझे आंसर चाहिए तो व्हाट शुड आई डिफरेंशिएट. तो साइन आंसर में चाहिए तो आई शुड डिफरेंशिएट कॉस. तो आई डिफरेंशिएटेड कॉस ऑफ 2x. I got the answer minus sine of 2x, but because differentiation follows chain rule, you differentiated the bracket over here and you got answer as 2. So minus 2, this minus 2 you cross multiplied it over here, and therefore minus 1/2 of whatever the term is. You can write this minus 1/2 inside. So you can also do it like this way, that you can say d by dx of minus 1 upon 2, d by dx of minus 1 upon 2 into cos of 2x is the value for sine of 2x. That means you have to in one way understand that if I integrate sine of 2x, my answer is going to be minus 1 upon 2 into cos of 2x. That is how you have learnt differentiation. So from differentiation, we'll slowly go to learn integration. तो आगे जाके थोड़े सम्स जब आएंगे तब हम डायरेक्ट इंटीग्रेट करेंगे, but first we are going through the method of antiderivative. So antiderivative of sine of 2x is minus 1 upon 2 cos of 2x. Now let's go to the next question. The next question is find antiderivative of cos of. So now next question, I want to find antiderivative of cos of 3x. I want to find antiderivative of cos of 3x. This is my second question. So second question में you want to find antiderivative of cos. Okay. Now you think and keep, what should I differentiate? तो I will get the answer cos. तो आपको पता है आप साइन को डिफरेंशिएट करते हो तो आंसर में cos मिलता है. तो I start my question like this. d by dx of sine of 3x. d by dx of sine of 3x is equal to cos of 3x. Is equal to cos of 3x. But I know the chain rule has to be followed in differentiation. So therefore, I differentiate the bracket over here. Sin x का cos x होता है. But if it is sine of 3x, some bracket term over here which is not simple x, I have to by chain rule differentiate that bracket again. So into d by dx of 3x into d by dx of 3x. So now, what was the differentiation of 3x? 3 is a constant and d by dx of x is 1. So the answer for this bracket is 3. So therefore, next step I will write here 3 cos of 3x. This is what it is, d by dx of sine of 3x. Now this 3, I'll cross multiply and bring it down. So 1 upon 3 into d by dx of sine of 3x is equal to cos of 3x. Now this 1 upon 3 which is outside, I can just take it inside over here 1 upon 3. So therefore I got, if I differentiate 1 upon 3 sine of 3x, I get the answer cos of 3x. So my question was find antiderivative of cos of 3x. यानी कि indirectly they are asking what will you get as an answer if you integrate cos of 3x. So if you integrate cos of 3x, the answer will be 1 upon 3 sine of 3x. Okay, this is how you are going to do. So the second question got over. You were supposed to calculate antiderivative of cos of 3x. तो antiderivative of cos of 3x यानी कि it is going to be, so this is how you calculated. Antiderivative means what will you derivate so that you will get the answer cos of 3x. And in other words, if you integrate cos of 3x, what is going to be the answer? So the answer is going to be 1 upon 3 sine of 3x. Okay, let's move on to the next question for antiderivative. So now the next question is e raised to 2x. So the next question is find antiderivative for e raised to 2x. So antiderivative for e raised to 2x. So third question is find antiderivative of e raised to 2x. So this is the next question. Now find an antiderivative. तो आप किसको डिफरेंशिएट करोगे तो you'll get the answer e raised to 2x. तो आपको पता है e raised to x का डिफरेंशिएशन e raised to x होता है, e raised to 2x का e raised to 2x होगा. भले चेन रूल बाद में फॉलो होगा, but e raised to something is, the answer is going to be back e raised to that same thing. So therefore I start with it in this manner, d by dx of e raised to 2x. So the answer you all know after, because now you have learned in differentiation. So the answer is e raised to 2x. So e raised to 2x ka differentiation is e raised to 2x. But if this power is not simple x, right? So by chain rule, you have to differentiate that power one more time. So into d by dx of 2x into d by dx of 2x. Now 2 is a constant, so you don't differentiate, and x ka differentiation will be 1. So answer for this differentiation will be 2. So therefore the answer is 2 into e raised to 2x. This is answer for what? D by dx of e raised to 2x. The answer is 2 into e raised to 2x. Now this 2 I'll cross multiply and bring it down over here. So d by dx of 1 upon 2, this 2 comes here down, into e raised to 2x. So d by dx of this term is equal to e raised to 2x. So we found antiderivative of e raised to 2x. So antiderivative of e raised to 2x is 1/2 e raised to 2x. So in other words, if you integrate e raised to 2x, what will be the answer? The answer will be 1/2 into e raised to 2x. So in other words, antiderivative of 1/2 into e raised to 2x is e raised to 2x. Let's move to the next question. So now next question is, that is question number 4. So question number 4, it is ax plus b whole square. Ax plus b whole square. I have to calculate the fourth question. My fourth question is calculate antiderivative of ax plus b ka whole square. Now how? So I know that what if you will differentiate. So what happens when you differentiate? Suppose you are differentiating x ka cube. So what answer you get? The power comes in the front and the power is now reduced by 1. तो it becomes 3x square. तो अब मुझे तो उल्टा करना है ना, तो 1/3 x का cube will give you x का square, right? This was with a small example. तो if I differentiate x cube, I'll get answer 3x square. तो therefore मुझे आंसर में ये x की जगह पे अभी full bracket is there. So what I do is I differentiate cube of the bracket. I differentiate cube of the bracket. So I differentiate d by dx of ax plus b का whole cube. I differentiate this term. So now you know how to do this. So therefore आप power को आगे लेकर आए, the power comes in the front, and whatever the base is, the power will be reduced by 1 if you differentiate. तो ax plus b का power will become 2. So अगर ये x cube होता तो answer would be 3x square. But since this is not a simple x term, so by chain rule we have to differentiate the bracket again one more time. So into d by dx of ax plus b into d by dx of ax plus b. So this is how it is. So therefore over here 3 into ax plus b whole square, and if you differentiate this, a is a constant, x ka differentiation will be 1 and differentiation of the constant term b will be 0. So this is going to be the term over here, and this is d by dx of ax plus b ka whole cube. Now you want the value for ax plus b ka whole square. So what I do is I let remain ax plus b whole square. I let remain here. So 3 and a, I bring it cross multiply it down. So 1/3a into ax plus b ka whole cube. So if you differentiate, if you do d by dx of this whole thing, this 3 and a you cross multiplied and you brought it down. So if you differentiate 1/3a into d by dx of, that is ax plus b whole cube, you will get the answer as ax plus b whole square. So therefore you learned antiderivative of ax plus b ka whole square is 1 upon 3a. In other words, if you integrate ax plus b whole square, the answer will be 1 upon 3a into ax plus b ka whole cube. Right? So this was your fourth question. Let's go to the next question then. Okay, so next is your question number 5. Find antiderivative of. Now, earlier all questions you had only single terms. So this question you are having two terms. Find antiderivative of sine of 2x and minus 4 into e raised to 3x. So what we will do is, we will do it in two parts. We will do it in two parts. First, I want to get the answer sine of 2x. So, I differentiate d by dx of cos of 2x. I differentiate cos of 2x. So, cos ka differentiation will be minus into sine of 2x, and when you differentiate 2x into d by dx of 2x. So therefore you will get it as minus 2 into sine of 2x, and this is d by dx of cos of 2x. Bring this minus 2 down here. So d by dx of minus 1 upon 2 into cos of 2x is equal to sine of 2x. Is equal to sine of 2x, right? So up to here I finished finding out antiderivative of sine of 2x. Now I find antiderivative of 4 e raised to 3x. So I start differentiating e raised to 3x. So e raised to 3x is equal to e raised to 3x only. The answer is going to be same. And into d by dx of 3x. So that is going to be 3. Differentiation of 3x is 3 into e raised to 3x. So therefore this is e raised to 3x and differentiation of that. Now bring 3 cross multiply it here. So I have d by dx of 1 upon 3 e raised to 3x is equal to e raised to 3x. So I found out antiderivative of both, but I have to have there, when I substitute my answers there, let me see what happens there. So my question was, I have to find antiderivative of that term over here. So therefore I say antiderivative of antiderivative of what you want? Sine of 2x minus 4 into antiderivative of e raised to 3x. So let me substitute the value then. Sine of 2x ka antiderivative is minus 1/2 it is d by dx of togetherly we will write for both. So d by dx will take common, d by dx of 1/2 into cos of 2x. This differentiation is for antiderivative of sine of 2x. Now minus 4 into e raised to 3x ka antiderivative, that is 1 upon 3, so it will become 4 upon 3 into e raised to 3x. So close this bracket over here. So antiderivative of sine of 2x and minus this would be First you individually found antiderivative of sine of 2x, then you found antiderivative of e raised to 3x, then you substituted the values here, sine 2x ka minus half into cos of 2x, then you had minus 4, तो minus 4, and e raised to 3x का 1 upon 3, तो 4 upon 3 into e raised to 3x. So this is how you finished your that question over there. Now let's further move to the next question. So now next question is at actual. Now you are not finding antiderivative. You are not finding antiderivative. You are directly finding the integration of the given terms. So till now, by the method of antiderivative, we were learning how would be the answer of the terms over there. तो antiderivative में antiderivative, तो what did you learn? Integration is nothing but antiderivative of a given term. Okay, तो this is how they taught you that कोई भी term का अगर आप antiderivative find out करोगे तो that is the answer for your integration of that particular term. Okay, now let's go to direct ways for integration. That is question number 6. 4 e raised to 3x, 4 e raised to 3x, that is question number 6 we are going to deal, and plus 1. I have to integrate this term, right? This is supposed to be integrated. Now there are small formulas which I had earlier told that you are supposed to know those certain formulas to follow smooth integration. Okay, so now जैसे डिफरेंशिएशन आप हर एक टर्म को अलग सेपरेट करते हो, we separate the integral for all the terms. तो over here 4 is a constant, तो integral of e raised to 3x into dx and plus integral of 1 and dx. So what did you do over here? So you had the term, two terms, you separated your integral for both of them. अगर constant होगा तो जैसे differentiation में you used to remove the constant outside before differentiating, here also you will remove the constant outside before integration. Now you had learned the antiderivative part right now. So if you differentiate e raised to x, answer is e raised to x. So if you integrate e raised to 3x, the answer is e raised to 3x only. So answer for integration would be e raised to 3x. Now when you were differentiating, आप चेन रूल फॉलो करते थे और 3x को दोबारा से डिफरेंशिएट करते थे. तो 3x को दोबारा से डिफरेंशिएट करोगे तो व्हाट वुड बी द आंसर? 3. तो इफ यू आर डिफरेंशिएटिंग आप मल्टीप्लाई बाय 3 लिखते थे अगर आप डिफरेंशिएट कर रहे हो तो. बट इफ यू आर इंटीग्रेटिंग यू डू जस्ट द ऑपोजिट, इट इज एन एंटी डेरिवेटिव. तो यू जस्ट डू द ऑपोजिट, यू डिवाइड बाय दैट आंसर ऑफ डिफरेंशिएशन. तो 3x के डिफरेंशिएशन का आंसर इज 3 and in integration we divide by that particular number. So the answer for that first term is 4 upon 3 e raised to 3x. Then plus 1. So earlier you know that d by dx of x is 1. d by dx of x is 1. तो अब उसका उल्टा करना है. तो d by dx of x, the answer was 1. तो उसका उल्टा क्या होगा? इंटीग्रेशन ऑफ 1 विल बी x. तो ओवर हियर हमेशा, नाउ यू विल रिमेंबर नाउ ऑनवर्ड्स दैट इंटीग्रेशन ऑफ 1 इज x. इंटीग्रेशन ऑफ 1 इज x. एंड हमेशा लास्ट में you have to write plus the constant of integration. तो first what do? You separate your integral signs for both of them, then you integrate and last में you write plus c, that is the constant of integration. Okay, this is one thing which has added over here. While differentiating you used to never do that. Now over here you will always write plus c, that is the constant of integration. Okay, now let's go to the next question. Okay, this is the next question. This is the next question. So you multiply x square with both of them. So first we'll simplify a bit. So x square, when you multiply with x, it becomes x square. Then minus over here we'll separate also at the same time, and integral x square into 1 upon x square. So that is going to be 1 and d of x. So we did two things at the same time. I multiplied x square to both of them, and then I separated my integral sign for both of them. So now I have here x square का integration will be, अब differentiation में क्या होता था, power a. Suppose you were supposed to differentiate d by dx of x का square, तो आप क्या करते थे, पावर आगे लिख लेते हो और x का पावर एक कम हो जाता है. एग्जैक्टली द रिवर्स थिंग इज गोइंग टू हैपन ओवर हियर. अगर आप इंटीग्रेट करोगे एक्स स्क्वायर को तो पावर विल इंक्रीज बाय 1. डिफरेंशिएशन में पावर डिक्रीजेस बाय 1. इंटीग्रेशन में पावर विल इंक्रीज बाय 1. एंड इफ आफ्टर डूइंग दैट, whatever was the power here, the same number you have to write it over here down. यानी कि अगर you are integrating x raised to n, तो what will you do? Answer में the power will increase by 1, तो it will become n plus 1, and upon जो भी power होगा, the same power you are going to write it down over here. तो this is the way you are going to follow in integration. डिफरेंशिएशन में पावर कम होता है और ऊपर वाला नंबर आगे रखते हैं. ओवर हियर पावर विल इंक्रीज बाय 1, एंड व्हाटएवर इज द आंसर, that number you will divide by that number over here, right? The exactly the reverse thing is happening over here. Now integration of 1, so I had already told you that integration of 1 is going to be x, and last में हमें constant of integration को add करना है over here. Constant of integration को add करना है, तो x cube upon 3 and minus x and then plus c. Okay, now we'll go to the next question, that is question number 8. Okay, so over here I is given to you, right? Now if I is some bracket, so what are you going to do over there? So you will separate your integral sign for all of them. So a is a constant, so you integrate x ka square dx, then plus b is a constant, you integrate x dx, and plus c into integral and dx. So what did you do? You separated your integral for all the terms. So now now integrate. So integration में what are you supposed to do, children? X का power you increase by 1. So if it is x square, it will become plus 1. So this will become 3, and whatever the power is, you will divide by that number. Then you go to the next term. B is a constant, x. तो what will happen? कुछ नहीं है का मतलब होता है 1. तो power will increase by 1. So this will become 1 plus 1. So that is going to be 2. And whatever the number was, you will divide by that number. Plus c. integral dx. Only integral dx means integral 1 dx. And you know that integration of 1 is always x. So into cx and plus the constant of integration over here. These a, b and c were small. You write the constant of integration as capital C, or you can also write capital, or C dash also you can write. Okay, so this is question number 8, and now we shall meet in the next class. Thank you, children.